friends, welcome back to the channel. Today we will talk about the verification techniques. In my previous video I talked about different types like functional verification and then formal verification and then timing verification and then power verifications. So if you have not seen or followed this video, please go and check this video in my video list. So today's talk will be more on the functional verification, but it is called the emulation. So just giving an introduction, talk of the emulation. Emulation is something where it is a software and hardware co-simulation. That means some part of the design is being simulated and some part of the design is being emulated. So if you follow till the end of this video, you will have a very good grasp of emulation techniques. This may not be in detail hands-on, but you will get a good concept on emulation technique. We first talk about why emulation. We have simulation itself for doing the functional verification, but still why we do need to know what is the emulation technique, because simulation has been a technique for quite a long, for decades. The VLSI engineers are doing checking the verification output through the simulation technique itself. So that means for a design you need to put some random test vectors and you need to judge the output of the circuit, by which you understand that what is the functionality of the circuit itself. But as you know, from decades, the design complexity has been increased a lot. So previously I have heard of something like 28 nanometer of technology probably when I started with it, then it gradually transferred to now it is kind of 3 nanometer or 4 nanometer technology itself. So with that 3 nanometer and 4 nanometer technology, lots of transistors are being emulated or integrated into a simple or single circuit itself. So if you want to do a functional verification with the help of simulation, it will take a long time, probably days or something, sometimes it is a week. So the designers and the VLSI technicians started thinking of some other technique. There lies the concept of emulation. So emulation is something where certain portion of the design we have simulation construct and certain portion of the design we have the hardware construct. So I will talk in detail what are those in detail in this video. If you have some idea about RTL, I hope that you have some idea about RTL, something like Verilog, that how the integrated circuit is being coded from English language to the Verilog language. So if you have not well aware of this, so I have a video on the verification introduction section where you can go and check that how the English language is being converted to a Verilog language. Verilog is something hardware description language, where the hardware is described in the form of language for the chip verification process. Now let's start with the RTL. RTL has different constructs, something like you have initial block, you have always block, you have different statements like $display, $monitor and forever begin, all these things. And you also have some block like always latch, always com and all these things, but those are more basically the extended Verilog type of construct. So the construct I talked about is basically something like display and monitor and all those things are basically required for printing the output of these things. So these are called simulation construct. If the forever begin and all these things that runs in a loop, those are all called simulation construct. So generally in our design, the verification engineers put a lot of those constructs in this Verilog language itself to do the chip verification process. So there is no point of doing the actual synthesis with this simulation construct itself. So that's why in emulation what happens is that certain portion of the designs are being sent to the simulator and certain portion of the design are being sent to the emulator. Till now I have not talked about the emulation technique, but think in mind that your hardware section will go to the emulator, your software section will go to the simulator. So for example, if you have a test bench, if you have a DUT, design under test, then your test bench you can directly pass to the simulation and your DUT you can directly pass to the emulation process itself. This video is meant for the introduction section of the emulation. So I will make another video where I will describe in detail about the emulation techniques that is being employed. So let me give you a summary of today's talk. First of all, I talked about Verilog, I talked about RTL, what are the simulation techniques, what are the simulation construct, I would say, what are the emulation construct, and more importantly, why emulation is required, because emulation has been a persistent technique that verification engineers used to employ, but due to the complexity of the chip design, the simulation will take a long time, so that's why emulation has come into the mind of verification engineers. And most importantly, straightforward, if you have a design which has a test bench, which has a design under test, you can directly pass the DUT to the emulation tool. You can directly pass to the simulation stuff, that is the test bench, to the simulation tool itself. So be with me, and in my next video I will certainly talk about what is emulation technique. But for now, I'm going to tell you signing off. But before that, I have recently published a new book called Semiconductor for All, and that is available in the Amazon. So I would suggest that if you are interested about semiconductor, if you are interested about artificial intelligence, then you can purchase this book, and it has 25 fascinating topic about semiconductor and the latest update about artificial intelligence as well. So with that, Subhasish Chakraborti signing off.